So we have this insane, talk about unbalanced, we have this insane situation where our science is finding everything is getting accelerating, getting worse, getting terrible, getting shocking, getting stunning. And on the other hand, our governments and institutions whose job it is to respond to this aren't responding at all. In fact, they're going the absolute other way. How do you put this? Our governments, our banking corporations, our fossil fuel corporations, they're killing us.
Hello, everyone, and welcome to today's Climate Emergency Forum. So we're still in the month of June, which the United Nations has named as the World Oceans Month. And today we're going to be discussing our polar oceans in peril. It's a very important topic. It deals with a lot of science jargon, and I'll explain one of the terms to you. But why are the polar oceans so important to us? Well, let me first explain that we have a twofold thing happening. First, nowhere else on the planet is climate change more in evidence than in the Arctic. And the Arctic itself helps to regulate the world's temperature. It's very important. So as more Arctic ice melts, the warmer our world becomes. Now, this introduces a positive feedback loop that affects the entire chain of events dealing with the oceans and the climate. That is, we have the Arctic, it's getting warmer, which means more ice melt, which means more ice exposed. And then the warmer ice that's melting, we have warmer water that gets underneath these ice sheets, which kind of forms little porous holes in the ice, which makes it melt even more. So with this warming world and the melting happening faster and faster, it is really threatening our entire global system and our way of life. So think of, if that didn't help, think of this positive feedback as, well, we've all heard about this horrible phenomenon that happens every few years where there's large crowds of people who get together and there's a stampede. It doesn't happen all at once. This is a positive feedback loop, just like the Arctic melting. So let's say, for example, you have 1 million people in the middle of Central Park and there's a sound, it's a bang. Someone popped off a firecracker. Well, a few people get scared and fear runs through a crowd like nothing. And people start running. And as more people see people running, they too get scared. It's like a contagion. And before you know it, you have a stampede of 1 million people running in a very confined space. This is a positive feedback loop. It can start small, but quickly get out of control. This is what we're seeing in the Arctic. And in the last 30 years, we've seen areas of Arctic sea ice that have melted, that these areas are larger than Norway, Sweden, and Denmark combined. These are entire nations. So it's truly frightening. And of course, we have to also realize with this melt and this feedback loop of further melting, we're also having an issue of maybe just minuscule sea level rise. And this sea level rise is something that may seem small and inconsequential, but all it takes is a little bit for things to go once again out of control. And then you have Miami, a city like Miami, flooding when there's absolutely no rain. So there's a lot of dangers with this happening in our Arctic. And I want to point out the dangers that are continued warming, sea level rise, and harm to the ecosystem. Harm to the ecosystem. We have so many animals that live in this area. It's one of the richest areas in terms of biodiversity. You know, these animals have evolved over millions of years to be able to tolerate a certain range of temperatures. And when these ranges of temperatures, just like us humans, go too high, they cannot survive or thrive, even reproduce in these new temperatures. So there's a lot to discuss and there's a lot at stake. And I'd like to turn it over to Dr. Peter Carter and see what he has to say on this topic.
Thanks, Regina. So I remember James Lovelock many years ago used to say, our planet and life on the planet likes to have ice, plenty of ice on the poles. So one of the reasons, big reason why we've enjoyed the past 10,000 years of relatively stable climate and we've been able to develop agriculture is because the poles have had a lot of ice and it's been pretty stable. There's a little bit of sea ice around the massive ice shelf of Antarctica, but up in the Arctic, as you mentioned, is particularly interesting and particularly important for the entire planet because we have a huge amount of sea ice floating on the Arctic Ocean. Now, shocking research reports are literally pouring in. And I'm going to start with one about ice. And this was a report of this year, and it was entitled Earth Ice Imbalance. And must say, I was absolutely stunned because this report from satellite data, et cetera, was able to show us how much ice, the glaciers and the sea ice and the sheets have lost. And the most ice that has been lost is the Arctic sea ice. The Arctic sea ice has lost 8,000 billion tons of ice. That's since 1994. Antarctica has lost some, but Antarctica sea ice tends to go up and down. It's lost 1,000 billion tons. So that's a massive amount of ice that the Arctic has lost. And of course, it's lost it by volume and also by extent. Now, I took a look at the PMS, which we've used a lot for sea ice volume. And I extrapolated the sea ice volume. And again, I got another shock because what this says is that we'll be at zero volume of Arctic sea ice by 2032. That's just around the corner. Sea ice volume is actually a much better, and this is why we've used it, much better than sea ice extent. Actually, the melt, as you've inferred, Regina, the melting is by volume. That's the primary melting which has been going on in the Arctic. It's actually volume melting. So this study just released by NASA and done in conjunction with NOAA satellite study gives a very accurate assessment of the energy imbalance of the Earth. And this is the worst, most stunning, most shocking climate science report that I can remember, because in just the past 14 years, the energy imbalance, which is the heat that's being retained in the Earth, in the climate system, has doubled. I mean, that is extraordinary. As the scientists have said, it's unprecedented, it's extraordinary. Nobody ever imagined that anything like this would happen. I mean, we've been warning people, Paul and myself and others, for decades now, that we're in an Earth emergency. I mean, my God, this is a dire emergency we're in. So interestingly, the scientists were able to break down why all this heat is suddenly being retained at a greatly increased rate. Of course, it's our greenhouse gas emissions in the atmosphere, greenhouse gases in the atmosphere. There's also the water vapor feedback that they mentioned. The water vapor feedback, as you get more warming, you get more water vapor, and that about doubles the effect of our emissions and the increased concentration in the atmosphere. But also, a major factor was the Arctic sea ice. A major factor was the Arctic sea ice feedback, which Regina has explained. Another factor was a change in clouds, which scientists say there's been a change in clouds, there's been a reduction in clouds as the lower atmosphere has warmed. So there you have it. Two massive, stunning, awful imbalances.
What you just explained, Peter, just sent chills through my spine. It's truly frightening. You're describing a blue ocean event in 10 years. And this brings up a whole other issue regarding the feedback. You know, a lot of people may say, who cares? I don't need sea ice. I live in New York City. I live in British Columbia. I live in Chile. But the thing that people aren't realizing is we're losing albedo. What is albedo? Well, the ice, everyone, is white. It's very, very light in color, and it reflects heat back into the atmosphere. But when we don't have it, it doesn't reflect the heat back. It takes it in, thereby exponentially increasing the water and by extension, the planet. And as Dr. Carter said, the water vapor, people don't realize that water vapor is actually, it's warming. It's a factor in the warming. Anyone who has spent time, say, in southern Louisiana and the summer understands that if it's 85 degrees with 90% humidity, you truly do feel like you're in a sauna. And it's because the water vapor adds to the heat index. So it sounds to me that we're having feedback upon feedback, which truly is frightening. Paul, have you heard anything about these increasing feedbacks?
Yes, along with the Arctic sea ice feedback from the loss of sea ice, there's all, and the clouds is a fairly, is one that has not been thought about or discussed too much in the climatologist community. I mean, clouds have always been one of the biggest uncertainties for the climate models, but the reduction of low-level clouds, as is in this latest report, is, you know, extremely concerning. And also, we're losing the snow cover on the land in the Arctic, and that's greatly reducing the albedo also. And the greenhouse warming, the greenhouse gases in the Arctic has of course been increasing because of the thawing permafrost and the warming water over the eastern Siberian Arctic shelf, for example, up to 5 degrees warming, which is thawing which is warming the sediments and thawing the methane clathrate rates there. So the methane rise in the Arctic methane's rising quickly in the Arctic, and we're seeing global upticks in methane globally. And I think the Arctic is a big reason for that. So all of these factors in the Arctic make the Arctic literally a darker place. It's not as reflective as it was. So NASA has an instrument called the CERES, CERES satellite system, and they've determined, I think it was from about 5 years ago. So they compared 2015, 2016 to 30 years prior and found that the albedo, or 20 or 30 years prior, and found that the albedo or reflectivity overall of the Arctic dropped from about 52% reflectivity to 48%. And so less snow and ice, a darker surface, and therefore more absorption of sunlight. And we know that the sunlight intensity, although the Arctic is dark for 4 months of the year, it's in 100% sunlight for the full day. In the summer, around the summer solstice in the Northern Hemisphere. And you've got 24 hours of sunlight on that dark surface. So the warming is getting incredibly quick and intense in the summers with the darker surfaces. And it's important to remember that the oceans transport about 1/3 of the energy that is transferred from the equator to the poles, and about 2/3 is transferred in the atmosphere. So we know in the atmosphere, the warming, reducing the temperature difference between the equator and the North Pole causes the jet streams to slow down and become much wavier. And we're seeing an enormous ridge over the southwestern US right now. So the US is setting record temperatures. And Of course, this leads to drought, and this over time, this will make parts of the U.S. Southwest uninhabitable a lot quicker than people think. We'll be talking about pipelines transporting water, not oil, to regions that are in drought to try to keep them inhabitable. And this is also greatly affecting our ability to grow food. So, we're going to have global food shortages, I think, within a decade, and that's going to lead to global famine. So that will really wake people up. Those are the consequences that will hit us hard and fast. So, what can we do about it? Well, there are different groups that are looking at different things. Is it possible to preserve some of the sea ice in the Arctic? There's a group called Ice 9/11 that talks about using little glass microbeads to reflect light, and these little microbeads are actually they would sort of mimic the glass shells of diatoms, for example. Other groups are looking at marine microbubbles, little microbubbles to reflect sunlight. And just before this just before this show, I was on a session with Metta Spencer from Toronto, who was talking with Peter Wadhams and Stephen Salter, who's behind the marine cloud brightening idea, the idea to produce low-level clouds to reflect sunlight. And if you do that over regions of warm water that flow up into the Arctic, you could cause some Arctic cooling. And there's also lots of different ideas. For example, if you cooled the water off the east coast of the US and reduced it to below 27.5 degrees, so reduced it to 2 or 3 degrees with marine cloud brightening, you could reduce the intensity of strong hurricanes hitting the coastline there, for example. So there's lots of different ideas, and I will discuss some of those also in my own videos on my own channel at paulbeckwith.net.
Thank you for that. And I always have to catch myself because I get so overwhelmed. And I get afraid too when I hear these bioengineering ideas, but I understand we're at a point where we have to think about these things. We have to think about them. And, people, again, it's just so far away and so foreign, and people will say, it's the Arctic, it's nowhere near me, but it's not like Las Vegas, right? What happens in the Arctic does not stay in the Arctic. It comes right to your back door. And I liked that you brought up the topic of the storms, because it affects that as well. We haven't even started summer. It is June 18th, for those of you who may be watching far afield from when we've taped this. We haven't officially started summer, but already there's a rather large tropical storm brewing in the Gulf of Mexico and making its way smack dab towards New Orleans. So these things are all interconnected. They are all interconnected. There is no over there, right? It's right here. And the oceans make up the greatest portion of this planet, which is why what happens in the oceans needs to be of primary importance to us. So, in terms of drought, flooding, agreed, very, very important things to consider. Peter?
Yep. The most important thing to do is to, yes, individually consider the situation that we're in. It's absolutely terrible. It's our duty to consider it, to talk about it, to discuss it. We're not nearly discussing this terrible emergency enough. And as the scientific research is coming in, as I said, everything is getting worse than the scientists predicted just a few years ago. And I mean, everything. Everything's accelerating. Everything's going at a faster pace than everybody ever imagined just a few years ago. There's another pretty stunning Arctic sea ice report, research again, which was presented with a short video just a couple of days ago by scientists at the Alfred Wegener Institute. They're an Arctic and Marine Institute. And what they have found is that there are already clear indicators of the melting rate of some of the Arctic seas that indicates that the Arctic will become ice-free in the winter as well as the summer. Now, scientists had thought that this would happen a long time ago. Now we have actual evidence. So what are our governments doing about this? What are institutions doing about this? They're doing worse than nothing, because they are all ganging up basically on us and the children all over the world and all future generations and all life, because they are pushing more and more and more fossil fuels, more and more fossil fuel combustion. So we have this insane, talk about unbalanced, we have this insane situation where our science is finding everything is getting accelerating, getting worse, getting terrible, getting shocking, getting stunning. And on the other hand, our governments and institutions whose job it is to respond to this aren't responding at all. In fact, they're going the absolute other way. How do you put this? Our governments, our banking corporations, our fossil fuel corporations, they're killing us. That's the only way that I can put it. I could say worse, but yeah, we have to really talk this up. We have to really address it. We have to really get this into the face of our governments, because they've just come off a 3-week discussion episode for the COP26 underneath the UN Climate Convention, and yet again they spent 3 weeks of discussion and agreed on absolutely nothing.
Truly frightening information, Peter. I will say nothing more, and wondering what Paul has to add to this discussion.
Yeah, so there's, let's discuss a few of the feedbacks that are going on in the Arctic. So most people are aware of the albedo or reflectivity feedback. The Arctic being darker, so it absorbs more solar energy, so heats much faster than the global average. There's, as the jet streams become wavier, the ridges go further and further north, and in fact they can go as high as the North Pole in the middle of winter, bringing temperatures above zero there, and they can go far enough south that they actually meet up across the equator and meet up with southern hemisphere jet streams. We also have, of course, lots of heat transported by the Gulf Stream going northeast across the Atlantic, and also by the Kuroshio Current, which goes off Japan, carrying lots of heat northward. And there's also lots of water. So there's lots of hot water from the North Pacific that goes into the Arctic. And there was a recent study showing the extent of penetration into the Arctic of this warm water and how it can, stop the ice from regrowing in the fall and winter. And there's also papers on the Atlantification of the Arctic, where the waters, the seas in the Arctic are becoming more and more, taking on more and more of the characteristics of the Atlantic Ocean as the warm water from the Atlantic goes underneath the ice as well. So the ice is being attacked on all fronts, by warming air, by warming ocean, on both the Pacific and Atlantic side. There's also, of course, Greenland is up there, and when we go to more and more loss of sea ice, and eventually no sea ice, as Peter said, the science is finally saying that there'll be no sea ice in the winter as well. And if you followed some of what I've been saying for many years, showing the biomass graphs of the sea ice decreasing in September and then tracking it down in all the other months, after the first blue ocean event where we lose sea ice in the Arctic for maybe a month in September, within 2 or 3 years, it's gone August, September, October, and within less than a decade, probably it's gone year round in the Arctic. And I think that's pretty clear. So basically the whole physical nature of the Arctic Ocean will change as we lose more and more sea ice, because right now the water, the Arctic is unique in the terms of the ocean column, the water column. As you go down, you have very cold fresher water at the surface, and as you go down, the water becomes saltier and it's warmer down below. So warmer water that is much saltier is actually a higher density than the cold water, which is fresher near the surface. So you get this sort of lens of fresh water on the surface from the ice melt, but then when the ice is gone or melted back far enough, the water column switches and becomes much more like the rest of the ocean, where the warm water layer is on top. And as you go deeper down into the water column, you get colder and colder. So of course, the completely changing physical nature of the seawater in the Arctic has tremendous ramifications for the marine life, and both in the water and also life that is on the ice and that uses the ice. So also the type of phytoplankton, all the way up the food chain, that switches as you lose the sea ice in the Arctic. So we're talking about massive wrenching changes. And once we kind of lock into this state where there's much less ice in the Arctic, we're in a totally different planet, essentially, because the jet stream, the global circulation patterns change, the motion of the jet streams and the currents changes and locks into a different type of situation. So there's a lot of unknowns. There's a lot of things that we do know, but there's also a lot of unknowns. But we do know there's the wrenching changes are afoot in the Arctic more than any other place.
This has been such an incredible conversation. I mean, I know the name of this show is Polar Oceans in Peril. It also could be renamed, I think, Fearful Feedbacks, because it's not just one thing. I mean, what Peter and Paul, what you've described is just one thing after another, So we have the melting permafrost, which emits methane, which increases warming, which increases water vapor, which increases the ice melt. It's just a never-ending catastrophe, it seems. We truly have to do something. And for those of you who are out there watching, I hope you don't feel too hopeless, because hope is the enemy of possibility. So yes, it's dire, but it's important that you're learning this, that we're learning this, that we're talking, so that hopefully we can do something. And I do want to thank you for sticking with us to the end. I do want to thank you for continuing to tune in to the Climate Emergency Forum. So please hit that subscribe button, hit the bell. When we have a new video out, you'll be the first to know. And I want to know what your thoughts are. What are your thoughts regarding the feedbacks that are promoted by this melting? What are your thoughts about the animals who depend upon the sea ice? Or what do you think about the blue ocean effect? Go ahead and put that in the comments below. We'd love to hear what you have to think. And once again, thank you for joining yet another Climate Emergency Forum.